From worldwideweb.++.com/doc/tutorial/. A double quote, learn by listening double quote, exercise. Part 10. C++ arrays. A double quote, array double quote, is a series of elements of the same type placed in contiguous memory locations that can be individually referenced by adding an index to a unique identifier. That means that for example 5 values of type int can be declared as an array without having to declare 5 different variables, open parenthesis, each with its own identifier, close parenthesis. Instead, using an array, the 5 int values are stored in contiguous memory locations, and all 5 can be accessed using the same identifier, with the proper index. For example, an array containing 5 integer values of type int called foo could be stored in memory according to this arrangement: double quote, foo, double quote, int 0, int 1, int 2, int 3, int 4, where each name represents an element of the array. In this case, these are values of type int. These elements are numbered from 0 to 4, with 0 representing the first and 4 representing the last of the 5 elements. In C++, the first element in an array is always numbered with A0, open parenthesis, not A1, close parenthesis, no matter its length. Like a regular variable, an array must be declared before it is used. A typical declaration for an array in C++ is : type name open square bracket elements right square bracket, semicolon. Where double quote, type double quote, is a valid C++ data type, open parenthesis, such as double quote, int double quote, or double quote, float double quote, close parenthesis, where double quote, name double quote, is a valid identifier, and the double quote, elements double quote, field, open parenthesis, which is always enclosed in square brackets, close parenthesis, specifies the length of the array in terms of the number of elements it contains. Therefore, an array to be named double quote, foo, double quote, with 5 elements of type int, can be declared as : int foo, open square bracket 5 right square bracket, semicolon. Note: the double quote, elements double quote, field within square brackets open square bracket right square bracket, representing the number of elements in the array, must be a constant expression, since arrays are blocks of static memory whose size must be determined at compile time, before the program runs. Initializing arrays. By default, regular arrays of local scope, open parenthesis, for example, those declared within a function, close parenthesis, are left uninitialized. This means that none of its elements are set to any particular value, semicolon. Their contents are undetermined at the point the array is declared. But the elements in an array can be explicitly initialized to specific values when it is declared, by enclosing those initial values in curly braces. For example, int foo, open square bracket 5 right square bracket equals, open curly brace 16, to, 77, 40, 12,071, close curly brace, semicolon. The statement declares an array of 5 contiguous integers, each containing one of the values designated within the curly braces, arranged, as listed therein. The array is named double quote, foo, double quote, and each of its 5 elements can be individually addressed using the name and digit contained inside a pair of square brackets, with a value between 0 and 4. When C++ source code uses this syntax to initialize an array, the number of values inside the braces must never be greater than the number of elements in the array. In the example above, the array named double quote, foo, double quote, was declared to hold 5 elements, open parenthesis, as specified by the number enclosed in square brackets, close parenthesis, and the braces contain exactly 5 values, 1 for each element. If declared with less than 5 arguments, the remaining elements are set to their default values, open parenthesis, which for fundamental types, means they are filled with zeros, close parenthesis. For example, int bar open square bracket 5 right square bracket equals, open curly brace 10, 20, 30, close curly brace, semicolon. We'll create an array containing the following integer values, 10, 20, 30, 0, 0. The curly braces can even be left empty, like this: int as open square bracket 5 right square bracket equals, open curly brace, close curly brace, semicolon. This creates an array named double quote, as double quote, containing 5 integers, each initialized with a value of 0, When an initialization of values is provided for an array, C++ allows the possibility of leaving the square brackets empty. In this case, the compiler will automatically calculate a size for the array that matches the number of values included between the braces, open curly brace, close curly brace, multiplied by the size of the associated data type : info, open square bracket right square bracket equals, open curly brace 16, to, 77, 40, 12,071, close curly brace, semicolon. After this declaration, array foo would be big enough to hold 5 integers, since we have provided 5 initialization values. Finally, the evolution of C++ has led to the adoption of universal initialization also for arrays. Therefore, there is no longer need for the equal sign between the declaration and the initializer. Both these statements are equivalent: Statement 0, 1 of 0 to info, open square bracket right square bracket equals, open curly brace 10, 20, 30, close curly brace, semicolon. Statement 0, 2 of 0 to info, open square bracket right square bracket, open curly brace 10, 20, 30, close curly brace, semicolon. As you can see from those two examples, the equal sign between the square brackets and the curly braces is completely optional. Static arrays, and those declared directly in a namespace, open parenthesis, outside any function, close parenthesis, are always initialized. If no explicit initializer is specified, all the elements are default initialized, open parenthesis, with zeros, for fundamental types, close parenthesis. Accessing the values of an array. The values of any of the elements in an array can be accessed just like the value of a regular variable of the same type. The syntax is : name open square bracket index right square bracket, where index evaluates to a number that is smaller than the maximum number of elements in the array, so that it can always designate exactly one of them. Following the previous examples in which foo had 5 elements and each of those elements was of type int, the name which can be used to refer to each element is the following: foo, open square bracket index right square bracket, where index would evaluate to a number between 0 and 4. For example, the following statement stores the value 75 in the third element of foo, foo, open square bracket to right square bracket equals 75, semicolon. Think of this as foo, element to gets a value of 75, and for example, the following copies the value of the third element of foo to a variable called x, x equals foo, open square bracket to right square bracket, semicolon. Therefore, the expression foo, open square bracket to right square bracket is itself a variable of type int. Notice that the third element of foo is specified foo, open square bracket to right square bracket, since the first one is foo, open square bracket 0, right square bracket, the second one is foo, open square bracket 1, right square bracket, and therefore, the third one is foo, open square bracket to right square bracket. By the same reasoning, its last element is foo, open square bracket 4, right square bracket. Therefore, if we write foo, open square bracket 5 right square bracket, we would be accessing the 6th element of foo, and therefore actually exceeding the size of the array. In C++, it is syntactically permissible to exceed the valid range of indices for an array. This can create problems, since accessing out of range elements does not cause errors on compilation, but can cause errors at runtime. The reason for this being allowed will be seen in a later chapter, when pointers are introduced. At this point, it is important to be able to clearly distinguish between the two uses that brackets have related to arrays. They perform two different tasks: one is to specify the size of arrays when they are declared, and the second one is to specify indices for desired array elements when they are accessed. Do not confuse these two possible uses of brackets with arrays. Two examples: Example 0, 1 of 0 to info, open square bracket 5 right square bracket, semicolon, / declaration of a new array. Example 0, 2 of 0 to foo, open square bracket to right square bracket equals 75, semicolon, / access an element of the array. The main difference is that the declaration is preceded by the type of the elements, while the access is not. For other valid operations with arrays, Example 0, 1 of 0, 4, foo, open square bracket 0, right square bracket equals x, semicolon. Example 0, 2 of 0, 4, foo, open square bracket x right square bracket equals 75, semicolon. Example 0, 3 of 0, 4, a equals foo, open square bracket x plus 2 right square bracket, semicolon. Example 0, 4 of 0, 4, foo, open square bracket foo, open square bracket x right square bracket equals foo, open square bracket to right square bracket plus 5, semicolon. Consider this 16-line sample program using arrays, which creates an array of 5 integers named double quote, foo, double quote, and initializes the 5 elements with the digits 16, 2, 77, 40, and 12,071. Each of those elements is then read and accumulated, one at a time, into a new, global variable named double quote, result double quote. After all 5 elements have been summed into double quote, result double quote, the total is displayed to the user, Line 0, 1 of 16, / arrays example. Line 0, 2 of 16, down sign, include open angle bracket, iostream, close angle bracket. Line 0, 3 of 16, using namespace std, semicolon. Line 0, 4 of 16. Line 0, 5 of 16, info, open square bracket right square bracket equals, open curly brace 16, to, 77, 40, 12,071, close curly brace, semicolon. Line 0, 6 of 16, indent, result equals 0, semicolon. Line 0, 7 of 16. Line 0, 8 of 16, int main, open parenthesis, close parenthesis. Line 0, 9 of 16, open curly brace. Line 10 of 16, 4, open parenthesis, n equals 0, semicolon, in left angle bracket, 5, semicolon, plus n, close parenthesis. Line 11 of 16, open curly brace. Line 12 of 16, result plus equals foo, open square bracket and right square bracket, semicolon. Line 13 of 16, close curly brace. Line 14 of 16, see out, double left arrow, result, semicolon. Line 15 of 16, return 0, semicolon. Line 16 of 16, close curly brace. Execution of this program results in the following output, which reveals the total of all elements of double quote, foo, double quote, 12,206. Multidimensional arrays. Multidimensional arrays can be described as arrays of arrays. For example, a bidimensional array can be imagined as a two-dimensional table made of elements, all of them of the same data type. For example, suppose we want to create an array of 15 integers that we want to name double quote, Jimmy double quote. Suppose further that we find it convenient to imagine these 15 integers arranged as 3 rows of 5 elements each. We can ask the C++ compiler to make this kind of arrangement in memory with the following syntax: int Jimmy open square bracket 3 right square bracket open square bracket 5 right square bracket, semicolon. And in any expression within the same scope, the way to reference that array's second element vertically and fourth element horizontally would be Jimmy open square bracket 1 right square bracket open square bracket 3 right square bracket. Open parenthesis. Remember that array indices always begin with 0, close parenthesis. Multidimensional arrays are not limited to 2 indices, open parenthesis, that is, 2 dimensions, close parenthesis. They can contain as many indices as needed. Be careful when defining large multidimensional arrays. The amount of memory needed for an array increases exponentially with each dimension. For example, the following declares an array named double quote, century double quote, with storage for a character corresponding with every second in an entire century : char century open square bracket 100 right square bracket open square bracket 365 right square bracket open square bracket 24 right square bracket open square bracket 60 right square bracket open square bracket 60 right square bracket, semicolon. Our array is conveniently arranged with dimensions for years, days, hours, minutes, and seconds. Unfortunately, this amounts to more than 3 billion characters, so this single array would consume more than 3 gigabytes of memory. At the end, multidimensional arrays are just an abstraction for programmers, since the same results can be achieved with a simple array, by multiplying its indices. Consider these 2 statements: int Jimmy open square bracket 3 right square bracket open square bracket 5 right square bracket semicolon slash is equivalent to int Jimmy open square bracket 15 right square bracket semicolon slash open parenthesis 3 asterisk 5 equals 15 close parenthesis. The only meaningful difference is that with multidimensional arrays, the compiler automatically remembers the depth of each imaginary dimension, which helps the programmer to visualize the arrangement according to the same layout. The following two pieces of code produce the exact same result in memory, but one uses a bidimensional array, while the other uses a simple array : sample 1 of 2 : line 0, 1 of 15, slash multidimensional array. Line 0, 2 of 15, down sign, define width 5. Line 0, 3 of 15, down sign, define height 3. Line 0, 4 of 15. Line 0, 5 of 15, int Jimmy open square bracket height right square bracket open square bracket width right square bracket semicolon. Line 0, 6 of 15, indent m semicolon. Line 0, 7 of 15. Line 0, 8 of 15, int main, open parenthesis, close parenthesis. Line 0, 9 of 15, open curly brace. Line 10 of 15, 4, open parenthesis, n equals 0, semicolon, and left angle bracket, height, semicolon, n plus plus, close parenthesis. Line 11 of 15, 4, open parenthesis, m equals 0, semicolon, and left angle bracket, width, semicolon, m plus plus, close parenthesis. Line 12 of 15, open curly brace. Line 13 of 15, Jimmy open square bracket and right square bracket open square bracket and right square bracket equals, open parenthesis, n plus 1, close parenthesis, asterisk, open parenthesis, m plus 1, close parenthesis. Line 14 of 15, close curly brace. Line 15 of 15, close curly brace. Sample 2 of 2 : line 0, 1 of 15, pseudo dash, multidimensional array. Line 0, 2 of 15, down sign, define width 5. Line 0, 3 of 15, down sign, define height 3. Line 0, 4 of 15. Line 0, 5 of 15, int Jimmy open square bracket height asterisk width right square bracket, semicolon. Line 0, 6 of 15, indent m, semicolon. Line 0, 7 of 15. Line 0, 8 of 15, int main, open parenthesis, close parenthesis. Line 0, 9 of 15, open curly brace. Line 10 of 15, 4, open parenthesis, n equals 0, semicolon, and left angle bracket, height, semicolon, n plus plus, close parenthesis. Line 11 of 15, 4, open parenthesis, m equals 0, semicolon, and left angle bracket, width, semicolon, m plus plus, close parenthesis. Line 12 of 15, open curly brace. Line 13 of 15, Jimmy open square bracket and asterisk width plus n right square bracket equals, open parenthesis, n plus 1, close parenthesis, asterisk, open parenthesis, m plus 1, close parenthesis, semicolon. Line 14 of 15, close curly brace. Line 15 of 15, close curly brace. Neither of the two code snippets above produce any output on the screen, but both assign identical values to the memory block called Jimmy . Note that the code uses defined constants for the width and height. This gives the code a better readability, and allows changes in the code to be made easily in one place. Also note the remarkable similarity between the two examples. Whether the 15 elements of the array are considered to be a single row of 15 integers or 3 adjacent rows of 5 adjacent integers each, the mathematics of locating any individual element relative to the beginning of the array are equivalent. Arrays has parameters. At some point, we may need to pass an array to a function as a parameter, so that the function can read or process one or more elements of the array. In C++, it is not possible to pass the entire block of memory represented by an array to a function directly as an argument. But what can be passed instead is its address. In practice, this has almost the same effect, and it is a much faster and more efficient operation. To write a function that can accept an array as an input parameter, the name of the array is declared within the parenthesis of the function definition or prototype in the usual way, but the name is then followed with a pair of empty brackets to let the compiler know that the parameter is to be treated as the address of the beginning of the corresponding array. The size of the array is omitted. For example, void procedure, open parenthesis, in arg open square bracket right square bracket, close parenthesis. This tells the compiler that the function, to be named double quote, procedure double quote, accepts a single parameter which should be used as the address of an array of integers, regardless of the name of the array in memory. Within the double quote, procedure double quote, function, it will be named double quote, arg double quote. Now suppose that there is an array of 40 integers in memory somewhere, to which the compiler has given the name double quote, myArray double quote. In order to give the function that we have named double quote, procedure double quote, access to that array, we would simply invoke the function and reference the array as an argument according to the familiar pattern, exactly as we might expect, with a statement like this: procedure, open parenthesis, myArray, close parenthesis, semicolon. The following program is a complete example coded into 17 lines. A new function named double quote, printArray double quote, is created, which expects to input parameters. The first of these will be interpreted as the address of an array of integers somewhere in memory, which will be named double quote, arg double quote, within the local scope. The second input parameter will be interpreted as the length of the array. Logic within double quote, printArray double quote, displays the values of every element of the input array. The program's double quote, main double quote, function creates two arrays of integers. The first of these, consisting of 3 integers, is named double quote, first array double quote. The second one, consisting of 5 integers, is named double quote, second array double quote. After populating these two arrays with hard dash, coded data, main calls printArray twice, passing it the relevant information about each of the two arrays. As result, the contents of each array are displayed as output. Here is the source code: line 0, 1 of 18 / arrays has parameters. Line 0, 2 of 18, $, include open angle bracket, iostream, close angle bracket. Line 0, 3 of 18, using namespace std, semicolon. Line 0, 4 of 18. Line 0, 5 of 18, void printArray, open parenthesis, in arg open square bracket right square bracket, in length, close parenthesis. Line 0, 6 of 18, open curly brace. Line 0, 7 of 18, 4, open parenthesis, int n equals 0, semicolon, in left angle bracket, length, semicolon, plus n, close parenthesis. Line 0, 8 of 18, cout, double left arrow, arg open square bracket and right square bracket, double left arrow, single quote, space, single quote, semicolon. Line 0, 9 of 18, cout, double left arrow, \n, single quote, semicolon. Line 10 of 18, close curly brace. Line 11 of 18. Line 12 of 18, int main, open parenthesis, close parenthesis. Line 13 of 18, open curly brace. Line 14 of 18, int first array open square bracket right square bracket equals, open curly brace 5, 10, 15, close curly brace, semicolon. Line 15 of 18, in second array open square bracket right square bracket equals, open curly brace to 4, 6, 8, 10, close curly brace, semicolon. Line 16 of 18, printArray, open parenthesis, first array, 3, close parenthesis, semicolon. Line 17 of 18, printArray, open parenthesis, second array, 5, close parenthesis, semicolon. Line 18 of 18, close curly brace. Execution of that program generates the following output: 5, 10, 15 to 4, 6, 8, 10. In the code above, the first parameter, open parenthesis, in arg open square bracket right square bracket, close parenthesis, accepts any array whose elements are of type int, whatever its length. For that reason, we have included a second parameter that tells the function the length of each array that we pass to it as its first parameter. This allows the double quote loop that prints out the array to know the range to iterate in the array passed. In a function declaration, it is also possible to include multidimensional arrays. The format for a 3-dimensional array parameter is base underscore type open square bracket right square bracket open square bracket depth right square bracket open square bracket depth right square bracket. For example, a function to be named double quote, procedure double quote, with a single multidimensional array as an input argument could be void procedure, open parenthesis, int myArray open square bracket right square bracket open square bracket 3 right square bracket open square bracket 4 right square bracket, close parenthesis. Notice that the first brackets open square bracket right square bracket are left empty comma, while the following ones specify sizes for their respective dimensions. This is necessary in order for the compiler to be able to determine the depth of each additional dimension. In a way, passing an array as an argument always loses a dimension. This because, for historical reasons, arrays cannot be directly copied, and thus what is really passed is a pointer. This is a common source of errors for novice programmers, although a clear understanding of pointers, explained in a coming chapter, helps a lot. Library arrays. The arrays explained above are directly implemented as a language feature, inherited from the C language. They are a great feature, but in actual practice they may be found to suffer from an excess of either size or speed optimization, and you may wish they were optimized for some other kind of performance. To overcome some of these issues with the arrays that are built into the language, C++ provides an alternative array type as a standard container It is implemented as a template, defined in header left angle bracket, array. Containers are a library feature that falls out of the scope of this tutorial, and thus the class will not be explained in detail here. Suffice it to say that they operate in a similar way to built dash in arrays, except that they allow array contents to be copied, an extensive operation that copies the entire block of memory, and thus to use with care, and decay into pointers only when explicitly told to do so, by means of its member data, Just as an example, here are two versions of the same example. The first example uses arrays as built into the C++ language. The second example uses the container library to handle its arrays. Example 1 of the language built dash in array. Line 0, 1 of 14, $, include left angle bracket, iostream. Line 0, 2 of 14. Line 0, 3 of 14, using namespace std, Line 0, 4 of 14. Line 0, 5 of 14, int main, close parenthesis. Line 0, 6 of 14, open curly brace. Line 0, 7 of 14, int myArray open square bracket 3 right square bracket equals, open curly brace 10, 20, 30, close curly brace, Line 0, 8 of 14. Line 0, 9 of 14, 4, open parenthesis, int I equals 0, I left angle bracket, 3, plus I, close parenthesis. Line 10 of 14, plus myArray open square bracket I right square bracket, Line 11 of 14. Line 12 of 14, 4, open parenthesis, int myArray, close parenthesis. Line 13 of 14, cout, double left arrow, double left arrow, \n, single quote, Line 14 of 14, close curly brace. Example 2 of the container library array. Line 0, 1 of 15, $, include open angle bracket, iostream, close angle bracket. Line 0, 2 of 15, $, include left angle bracket, array right angle bracket. Line 0, 3 of 15. Line 0, 4 of 15, using namespace std, Line 0, 5 of 15. Line 0, 6 of 15, int main, open parenthesis, close parenthesis. Line 0, 7 of 15, open curly brace. Line 0, 8 of 15, array left angle bracket, int, 3 right angle bracket, myArray, open curly brace 10, 20, 30, close curly brace, Line 0, 9 of 15. Line 10 of 15, 4, open parenthesis, int I equals 0, I left angle bracket, myArray point size, open parenthesis, close parenthesis, plus I, close parenthesis. Line 11 of 15, plus myArray open square bracket I right square bracket, Line 12 of 15. Line 13 of 15, 4, open parenthesis, int myArray, close parenthesis. Line 14 of 15, cout, double left arrow, double left arrow, \n, single quote, Line 15 of 15, close curly brace. As you can see, both kinds of arrays use the same syntax to access its elements, myArray open square bracket I right square bracket. Other than that, the main differences lay in the declaration of the array, and the inclusion of an additional header for the library array. Notice also how it is easy to access the size of the library array.